G'day, welcome back to the channel. My name's Matt, but you all know me as WFX Malice. Today I'm going to be showing you how I designed and 3D printed this Bluetooth speaker. Wait, what? Out of spare parts that I had laying around my workshop. So, let's get started. So the limitations on this project was I had to use spare parts I had laying around in my shed. I couldn't purchase anything new. So obviously the case I 3D printed, the 18650 cells come out of a laptop battery, the amplifier, the speakers, the passive radiators, the balanced charging board, the buck converter, the wiring, the switch, the charge port, and the 12-volt transformer was all spare parts I had laying around from old projects. Now, strange list of things to have sitting around in your shed, but look, about 3 years ago, I had a Pioneer home theatre sub and nothing to plug into. So I decided to turn it into a 2.1 channel portable Bluetooth speaker. So I went and bought this 2x50 1x100 D-class amplifier. It was pretty high end. Had a couple of MOSFET chips on it from memory. I ran 12 18650 cells in it, running in series and parallel. Couple of 6.5-inch Pioneer car speakers mounted in some teardrop pods on the side. The thing ran for about 36 hours straight without needing to charge. It was amazing. And then other people started saying, hey, can you build me a speaker? And so I started just stockpiling electronics from around the place. Some of it I bought from eBay. Some of it was stuff I salvaged out of other old home theatre systems and laptops. Some of it I bought when I was over in Tokyo around Akihabara, or as we call it here in Australia, Akihabari. Just stuff I picked up while I was roaming around the streets there. It is an amazing source of electronics there. There's a lot of junk, but there's also a lot of high-end stuff. So if you know what you're looking for, yeah, go for it. This project took a lot longer than what I was originally hoping, and it's all to do with print failures. So between mechanical failures and between filament failures, I wasted about 2 days of failed prints. And if you look carefully at the finished product, there was actually a print failure, which I managed to catch. I don't know if you can see that at about the 3/4 mark, right the way around, there is a gap. And like I said, I managed to catch it. I was playing some computer games, and on my second monitor, I have my 3D printer running through Octopi, which allows me to monitor my print jobs. I can see the webcam. I can pause, stop, resume, cancel my print jobs on the fly. So I saw it was printing nothing. I managed to catch it one layer above where it had failed. So I hit pause, finished my game, went out, fixed up the filament, pushed it back in, used the baby steps adjustment to take it back down about 0.5 mil and continued printing, and it carried on. So luckily, this is a 22-hour print, this back case here. I really didn't want to have to go through it all again because that would have taken it out to probably a 5-day print job. So where the print had failed, I went and ran a bead of super glue around just to make sure it had some decent structural integrity. So on that, if you're looking to join, repair, patch your 3D prints with PLA, you're going to want to grab yourself some of this. This is the best stuff I've found that works. And I love what it says down the bottom there as suggested uses. Porcelain, metal, rubber, leather, wood, plastic, or paper. Hey Mum, I'm looking to join 2 bits of paper. Oh, use the Loctite super glue. Oh, thanks Mum. Get out of here. I grabbed mine from Bunnings, so if you want to head down and grab some, make sure it's a Saturday or a Sunday, because otherwise you won't get your snag. And have you actually been to Bunnings if you don't get a snag? So, getting back to the electronics of this. So, it's powered by 3 18650 lithium-ion cells. These are commonly found in laptop batteries, which is exactly where these units have come from. The batteries ended up in my junk pile because it was no longer holding any charge, and that usually means that there's one dead cell amongst them all. So in a laptop battery, you could have 3, 6, or 9 cells running series and parallel, or in this case, just in series. And one dead cell can mean the whole battery won't hold charge. So what I do is I go and take them apart, put my multimeter between all the cells, find out which one or ones are dead, and then give them a jump start. Now, this is highly dangerous. I don't recommend you try this at home, but essentially you put a high amount of voltage and a high amount of amps into this battery for a particular time frame, and then you can go and connect it to a smart charger or a balanced charger. Once again, I say don't try this at home unless you know what you're doing and you've got the correct safety equipment nearby. Do it in a ventilated area outside. If you put too much charge into one of these batteries, it's the same as discharging a battery too quickly. It'll get hot and potentially catch fire or explode. Samsung Note users know what this is all about. These batteries are Samsung cells. They are high end. You can pick them up on eBay for about $15 to $20 brand new. You can pick them up for about $10 second hand, which would be refurbished like what I've just talked about there. You've got to be careful because you're not always going to get quality, and it's not always people have charged them up in the correct manner. If you see anything really cheap or really high amp hour, be aware sort of anything above 4,000 milliamps or 4 amp hour is probably an indication that it's fake, cheap Chinese junk that's been re-sleeved. A lot like the old 2 terabyte micro SD scam where you got a 4 gigabyte memory stick and paid $30 or $40 for it. We've all seen that. We've all been there and tried it. Be aware, eBay isn't always your best source of this sort of stuff. So the next thing you want to do when you're running these things in series or parallel is you want to charge them off of a balanced charging board or a smart charger. So in this case, I'm using a balanced charging circuit, which what it does is it connects negative to positive end of the 12 volt battery, which is your 3 cells of 4 volts each. And then you've got sensor wires that go between batteries 1 and 2 and batteries 2 and 3. And basically what they do is they ensure that the 12 volts are being distributed evenly between all of the cells. So each cell is getting 4.2 volts charge up. That way, we're not going to overcharge one cell or undercharge another cell, or potentially cause a fire inside of our electronic device. Highly essential, highly recommended. From there, what we do is we run a step-down voltage regulator or a buck converter. Takes that 12 volts and turns it into 6 volts. That powers the amplifier. So I don't have any specs on this particular amplifier. I bought this about 3 years ago off eBay. It is quality Chinese junk. I can't find anything on it as far as serial numbers or models to bring up any specs. I don't even know how many watts this amplifier is. I'm assuming it's about 10 watts, might even be a bit lower. The amplification chip on there doesn't look very high-end or quality. It was something that I just bought because it was cheap. I think I bought it because I bought a bunch of other cheap stuff, and I sort of felt guilty making these guys ship over like $4 worth of stuff to Australia. So I went and bought this amplifier, which is another thing in their listing. I tend to do this sometimes, and you're just buying things because you don't really need it, but you sort of feel guilty for the seller. That's me. So the amplifier itself just connects straight directly to the speakers, and that's pretty much the short end of it. There is a switch that runs between the battery and the buck converter because you want to be able to isolate that when you're not using it. If you leave the power running from the battery to the buck converter in your isolator on the amplifier side, that buck converter is always using power. It's always going to be using generating heat inside of there, and once again, potentially you could create yourself a fire or an explosion. So make sure that you put your isolation between the buck converter and the power supply. There is also a charging port which connects directly to that balanced charging board naturally. And then I've got a 12 volt 2 amp transformer which I purchased years ago. I bought about 3 or 4 of these for a particular project and never ended up using them. So that is the electronics inside. So while I didn't do a full tutorial on how to build this, I was going to do a time lapse, but it would have taken far too much effort and it probably wouldn't have done the build any justice. So it's probably easier if I just walk you through it. This is the back case. We've got a nice little step down in here for the passive radiators to sit into, a hole for the switch, hole for the charge port. These are our mounting points for the speakers, and I've done it this way so that I didn't need extra faces and extra bits and pieces. When I originally designed it, there was going to be a back case, there was going to be a mid case, there was going to be the front cover and possibly a 4th section to it. And it was just going to be too messy, too much going on, so I just kept it as simple as possible. It's got a nice little lip in here, as you can see, for the lid to sit into, and the lid has obviously the matching step-in there to match up nice and neatly. I'll quickly show you the design of the mesh, the grill, because this is quite neat and tidy. As you can see, everything is constrained properly, and it's all because this hole here and this hole here are the only two holes actually on the drawing for the mesh. All the rest of them are a pattern from those, which is a very simple way of doing things. Keeps it nice and neat. I did go and put some mesh holes in the center part here, even though I didn't really need it. But because there's electronics, there's a lithium battery, electronics get warm and hot, so I thought we'll put some holes in there for it to breathe. Now also, the point behind this step down is on the front of the speakers, there is a rubber ring, and the idea is that rubber ring will sit in there and seal off so that it'll stop things from rattling around and also keep the sound within each chamber. Let's have a look at the 3D print now. Time for the conclusion, and I'm going to do this conclusion as a bit of a comparison. On this side here, we've got the Sony SBS XB30 versus homemade speaker. I'll start with the Sony. So Sony cost me about $190, gets about 6 to 8 hours of continuous play time. They say 12 hours in the packaging. No, it does have a extra bass button on there. I don't know if you can see that. If you turned off the extra bass and run it in suck mode, yeah, you're probably going to get 12 hours, but who listens to a portable speaker in suck mode, right? It's got bass in it, you want to use it. On that note, yes, the sound is good. Very well matched amplifier to speakers, very good construction. They've done well getting the right sound pressure level inside, made good use of the passive amplifiers front and back. Really good volume, really good sound. Does have a UI here on the top. I've never used it. It's got a phone button for calling. Hello. It's got a play, a plus and minus for your volume, and an add button. Apparently you can add multiple of these speakers together. Don't know why you'd do that. I think you'd probably just get the bigger speaker, because you could buy like a big floor standing speaker for like the price of 2 of these. On the back panel, charging port USB, so you can charge a device off of this. I don't know how big a device you'd get to charge off of the little battery that's inside it. A proprietary charging port. I did lose the transformer for this, and I couldn't find another transformer that would plug in and fit. Nothing here came close to fitting, so it was basically a house brick for like 2 or 3 months. It does have an aux cord for audio input. Once again, I've never used it. It's a Bluetooth speaker. Come on, you know, get with the program, Sony. Over to homemade speaker. Cost, including all the PLA from the faulty prints, I'd say $40. If you want to include the power transformer, I'd say probably another $15, $20. But I'm not really considering that as a cost to this, because it's only going to be being charged once every now and again, and that transformer can be used on many other devices. Sound, yep, we've already discussed. The amplifier is starving these speakers. They really want some more grunt, and that amplifier is just not going to do it. I am considering upgrading the amplifier. Runtime on this, massive. Those 650s at 2.2 amp hour, I'm predicting this thing will run for about 18 to 20 hours as a minimum. I've already run it for about 5 or 6 hours. There is heaps of grunt in the battery. It hasn't even put a dent in it. So yeah, huge runtime, but lacking in volume. So I guess if we bumped up that amplifier to give it some more volume, it might drop those hours down a little bit, but I don't know. I got a lot of faith in those 18650s. Very good batteries. Not waterproof. The Sony obviously is. No external buttons. Nice and clean. Nice and neat. Power button is obviously the only thing on there. Design, nah. It's a very ugly looking thing. I mean, it looks cool. It sort of looks a bit retro, but I'm considering redesigning this front face to give it some contour out and perhaps some nice rounded donut type sunk in areas for where the speakers are and get rid of the grills altogether. Maybe, don't know. But yeah, that could definitely be improved on. That was just, I guess I got lazy at the end of the design and just went, just give it a faceplate. Just get the job done. So yeah, could be a little bit better looking. It's not as robust as we discussed as well. That print failure has really taken my faith out of the strength in this thing compared to the Sony, which I know I can just throw around. All in all though, great speaker. Am I happy with it? Yes. Would I do it again? Yes. Is it worth it? Yes, 100%. Great cheap thrill speaker. Something to take around, something to throw down at the park, listen to some music. It's not going to be terribly loud, so it's not going to bug everyone, which is ideal, really. If you want to be obnoxious and annoy people with loud music, well, you can bring the car down and, I don't know, open the boot up or whatever. But anyway, look, I'm just ranting now. Hopefully you guys have liked this. Hopefully you've learned something. Hopefully you've got some inspiration to go and build something for yourself. My design is going to be uploaded to the Thingiverse as always. I'll throw on the F3D files as well as the STL files. So you can go and print one of these. I think there's 75mm speakers and 40mm passive radiators. I'll confirm that. So yeah, link down the bottom for my Thingiverse page. Look, if you have got something out of this and you have enjoyed this, please hit the subscribe button. I've got hundreds and hundreds of views so far on my videos, and I've got a handful of subscribers. Subscribing costs you nothing. Just click the button, job done, get over it. If you don't want to get notified by my videos, it's easy. Just don't click the bell. It's quite simple. I don't click the bell on people's pages when I subscribe. I just go into my subscription list and check out to see what new videos that come up from people that I want to watch. It's that simple. Anyway, thanks for watching, guys. I'm going to take this out with a little bit of sound from my speaker. Music in this clip today has all come from a good friend of mine, Van D. Check him out on SoundCloud. I'll also throw a link. He hasn't done anything recently, but definitely check him out and show him some love. Thanks for watching, guys. See you next time.